Welcome back. Every day we see many living things moving around us. Even the non-living things can move if we exert some pressure on it. Most of you might be football fans, right? If the player kicks the ball will start moving and after some time it stops. This is due to the friction on the ground. In this chapter, we will discuss about the various types of forces and their effects. In our day-to-day life, we do a lot of activities like picking, holding, opening. In all these activities, the position of the object changes. For example, if we need to shut a door, we need to push it, and if we need to open the door, we need to pull it. Likewise, if we want to draw a bucket of water from the well, we need to pull it, and if we want to move a cart, we need to push it. In all these activities, there is a push and a pull. This push and pull on objects is called the force. The force changes the object's direction. Like when we kick the football, it changes its direction. This is called the direction of force. Forces are due to interaction between two objects. For example, imagine the scenario that your car has some starting trouble and you are trying to push the car so that it can move. When you are pushing the car, you are exerting some force on it. This force is there due to the interaction between you and the car. Take another example that a man is trying to pull a running horse. Here both the horse and the man are pulling and the force come into action due to the interaction between the horse and the man. Now exploring forces. Imagine that you are trying to push a heavy cart. Alone you might find it difficult and you are taking the help of your friend. If both of you are standing in the same side and you are pushing the cart will move very easily. But if your friend is standing on the opposite side and pushing it, what will happen? If you are stronger than your friend, then the cart will move towards your friend. And if your friend is stronger than you, then the cart will move towards you. The total force on an object is called the net force and the effect on the object is due to this net force. That means if both of you have same strength, then what will happen? The cart won't move. It will stand in the same position. As the net force applied is 0. And when both of you are standing in the same side and pushing the cart, then the cart will move easily because the net force is the sum of the two forces applied. And when both of you are on opposite sides, then the total force or the net force is the difference between the two forces and the cart will move in the direction of the larger force. If two forces are applied on the object are equal, then the net force is 0. That means both of you are have equal strength and both of you are pushing the cart from opposite sides. Then the net force is 0. If two forces applied on an object in opposite direction, net force is the difference between the two forces. That means the cart will move in the direction of the larger force. If two forces applied on an object in the same direction, then the net force will be the sum of the forces applied. The strength of the force is expressed in magnitude. And if the direction and the magnitude of the force changes, then the effect on the object also changes. A force can change the state of motion of an object. An object can be at rest and in motion. First, let us see what will happen if we exert some force on a stationary object. You all might be familiar with the penalty kick in football. Before the player kicks the ball is at rest, speed is 0. But when the player kicks the ball gains some speed and it starts moving. For this, let's do one experiment. Take a rubber ball and place it on a smooth surface. Now gently push it so that it can move. Now push it again while it is moving. What will happen? The speed of the ball increases. Now place your palm on the path of that ball. The ball will come to rest. From this, we can conclude two things. A force can make a stationary object move and a force can make a moving object stop. Now, take the same example as the penalty kick in football. Now, the ball comes in this direction and when the goalie blocks the ball changes its direction. For this, let's do the same experiment with the rubber ball. Place the rubber ball on the tabletop and gently push it and then place a ruler on the path of the ball. When the ball touches the ruler will exert a force on the ball and the ball will change its direction. From this, we can conclude that the force not only increases the speed of an object but also changes its direction. A change in the speed or direction or both is said to be a change in the state of motion of an object. A force can change the shape of an object. You all might have observed your mom making a chapati or roti. When she exerts a force on the ball of dough, what will happen? The shape of the dough changes. Likewise, when you pull a rubber band which is suspended from a hook, the shape of the band changes, it gets elongated. From this, we can conclude that a force can change the shape of an object. Let's recap what are the effects of forces. It can move an object from rest, it can change the speed of an object, it can change the direction of a moving object, it can change the shape of an object. Now, forces are two kinds, contact force and non-contact force. Examples of contact force are muscular force, frictional force. Examples of non-contact forces are magnetic force, electrostatic force and gravitational force. Let's see what is the muscular force. Can you lift a bag lying on the table without touching it? Or can you carry a bucket of water without holding it? The answer is no. If you want to perform these activities, you have to come in contact with the object. To perform these activities, you are using the muscles in your body. The forces resulting due to the action of muscles is termed as muscular forces. In villages, people are using animals for a lot of activities. To perform these activities, animals also apply the muscular force. Moving on to frictional force. When you kick a ball, it will start moving and after some time it stops. This is due to the friction between the surface and the ball. When you switch off an engine of a boat, it will stop. This is due to the friction between water surface and the boat. Likewise, if you stop pedaling a bicycle, it will slow down and stop. This is due to the friction between the road and the tires of the cycle. This frictional force always act in the opposite direction of a moving object, and this frictional force can only happen when two objects come in contact with each other. Moving on to non-contact force, magnetic force. You all might be familiar with magnets. When you place a magnet near some iron nails, what will happen? These iron nails will jump towards the magnet and stick to it. Magnetic force can happen without the contact between two objects. Let's do one experiment. Take two identical magnetic bars and place one of the bars on the top of three wooden rollers. Now bring the north side of one magnet to the south side of this magnet. What will happen? The opposite poles attracts each other and the magnet which is on top of the wooden rollers will move towards the other magnet. Now let's do one more experiment. Bring the north side of the magnet to the north side of the other magnet. What will happen? The same sides repel each other. The magnet which is on the top of the rollers will move away from the other magnet. Now electrostatic force. Let's do one experiment. You all might be familiar with this. Rub a ruler on dry hair and place it near to some small pieces of paper. What will happen? The paper will jump and stick to the ruler. This is due to electrostatic force. When we rub the ruler on dry hair, it gets some charge. This is termed as electrostatic charge and the object is termed as a charged body. The force exerted by a charged body on a charged or uncharged body is termed as electrostatic force. Here the charged body is the ruler and the uncharged body are the papers. We all know that when we drop something, that object will fall directly to the ground. This is due to the gravity of the earth. When we hold a ball in our hand, the ball is at rest. But when we leave it, the state of motion of the ball changes. This change is due to the action of gravity of the earth. All objects in this universe exert a gravitational force on another object. Not only Earth has gravity, all the other planets have gravity. And this will be greater than or less than the gravitational force of the Earth. Now pressure. If you try to push an iron nail to the wall by its head, will you succeed? Or if you try to cut a vegetable with a blunt knife, it is very hard to cut that vegetable. Why? The reason behind is that the force exerted by your hand falls on a larger surface area and the resulting pressure will be very less. When we use a sharp-edged knife, then the force applied falls on a very small surface area and the resulting pressure will be very high. You might have given your luggages to the porters in the railway station. Have you noticed what they do? Before picking the luggages, the porter places a cloth over his head. This is to increase the surface area so that the pressure exerted by the luggage is very less and he can carry the luggage without much difficulty. If we want to pierce or cut something, we always use sharp-edged objects. This is to decrease the surface area and to increase the pressure. The force applied on a unit area is known as the pressure. Now pressure exerted by liquids. Water, oil, petrol and all the other liquids exert some pressure on the wall and bottom of the container. To understand this, let's do one experiment. Take a glass tube which is of 5 cm in diameter and 25 cm in length and then tie a balloon stretched on the other end of the glass tube. Now pour some water into the glass tube and now mark the level of the water. Now we can see that the balloon bulges out. This is because the water exerts some pressure on the bottom. Liquid exerts a pressure at the bottom of the container. That's why the balloon bulges out. Now pour some more water so that the water level increases beyond this mark. Then we can see that the bulge in the balloon increases. This is because pressure exerted depends on the height of the liquid column. If the height of the liquid column increases, then the pressure exerted will also increase. Let's do one more experiment. Take a soft drink can and make a hole just above the bottom by inserting a hot glass tube inside and then seal the sides with molten wax. Now tie a balloon stretched on the other side of the glass tube. Now pour water into the container. What will happen? We can see the balloon bulges out. This is because the water exerts some pressure on the walls. Liquid exerts pressure on the walls of the container and the pressure exerted is greater when the height of the column increases. Let's do one more experiment. Take a plastic bottle and make 3 holes which are of same size and of equal distance from the bottom of the bottle. Now fill the bottle with water. What will happen? The water falls through the holes, right? The water will fall in same distance from the bottom of the bottle. That means a liquid exerts pressure equally when they are at same depth. Now take another bottle and make 3 holes at different depths, but it should be of same size. Now fill the bottle with water, and now we can see that water falls through the holes will fall at different distance from the bottom of the bottle. This is because liquid exerts pressure differently at different depth. Now pressure exerted by gases. Like liquids, gases also exert some pressure. When we inflate a balloon, after inflating the balloon, we have to immediately close the mouth of the balloon. Otherwise, the air will escape. If we try to inflate a balloon with holes, what will happen if it has holes? The air will escape through all these holes. From this, we can conclude that air exerts pressure and air exerts pressure in all directions. The gases exerts a pressure on the walls of the container. Atmospheric pressure. We know that we are surrounded with air, that is called the atmosphere. The atmosphere extends up to 300 km from the Earth's surface. We know that every object on the Earth has weight due to the gravity. So tremendous amount of air is there and it has tremendous weight. This weight will exert a pressure on the Earth's surface, right? That is called the atmospheric pressure. If you imagine a unit area and place a cylinder over that, then the air inside it, then the weight of the air inside that cylinder is called the atmospheric pressure. The pressure exerted by atmospheric air is called atmospheric pressure. To understand the magnitude or the strength of atmospheric pressure, let's do one experiment. Take a rubber sucker, then push it hard to a smooth surface. What will happen? The sucker will stick to the surface, right? And it gets flattened. This is because the air inside this cup and between the surface will escape out. Now, the atmospheric pressure from outside will exert a great force on this sucker. If we try to pull it, it is very hard to pull it, right? If we want to pull it, we have to exert a force which is greater than that of the atmospheric pressure. Then only we will succeed in that. If you like this video, please share it with your friends, and if you have any queries, please put it in the comment box. Thank you.